the previous videos, we mentioned about the general nodes, which typically found in the structural key plan. It gives a lot of informations which can be classified into two main parts. One as the table of content for all the structural key plan produced by the engineers. Another one, it will cover all the aspects related to the structures, which has been standardized across the board throughout the entire building. This will include the core of practice applied, the properties of the materials, the concrete cover, the lapping length, the bending radius, and several standardized designs. You will need to take all this into considerations when you're actually producing your key plan. In fact, all these need to be designed properly, not just providing the layout of the beam, as well as providing detailings of the beams and slabs. By looking at the illustrations given in the structural plan, there will be a lot of missing informations. For example, the contractor do not know what grade are you using. It is only when they look into your demonstrations of your calculation step in the design report, then they realize that the concrete grade that you use. The illustration also never give you information regarding the concrete cover. You cannot allow the contractor to assume by themselves, as you know that the concrete cover can influence your effective depth, which are used to resist the bending moment, and it's also affecting the exposure conditions of the structural element, as well as the fire resistance rating. The contractor may not know your design. All this needs to be clearly spelled out to them to avoid any guessing and ambiguities. As for the lapping length, it should also be clearly stated. You should standardize the lapping length, because different engineers may use different values. Some may go for 50, some may go for 46, and some may go for 52 times the bar diameter. There are different considerations, and you know that the calculated lapping length, it is very much dependent on various factors, such as the concrete grade, the locations of the lapping, whether it is a good bond regions or poor bond regions, and other factors. This will be explained in the course Reinforced Concrete Design 1 later. There will also be some standardized design for certain structural elements which are not given in the detailings and the structural key plans. This provides them guide how to produce those elements to be used in the construction site. The entire idea here, you have to have everything properly stated to the contractor, which all this may differ from project to project, as governed by different design considerations, and to avoid confusions of the contractors that are responsible to build the structures. Next, in these videos, we're going to discuss further about the key plan in terms of what kind of information that you need to incorporate in the key plan, as well as some insights related to the key plan. First, your structural key plan, it should be on basis of the architectural drawing, as you need to derive from there, and the layout of your beam, the size of your slab, it will be very much dependent on the layout of the floor plan given by the architect. As an universal reference, you should use the similar gridline system as given by the architect, this including the numbering system. Taking this as an example, the grid line here, it will be x1, x2, x3, and x4. The vertical grid line, it will be y1, y2, y3, and y4. Therefore, later when you need to produce your structural key plan, you're going to make all the horizontal grid line to be in x and all the vertical grid line to be in y. And you should adopt the same numbers in the same locations of the grid line. That will be the bare minimum. Of course, for easy referencing, especially when there are grid lines somewhere in between the main grid line, something like this, you will need to provide another numbers for the grid line as the subgrid line for the existing main grid line here. Probably I will put this as x3a, and if I have another grid line, it will be x3b. Similar principle applies to the other grid line here if it is not clearly stated in the architectural drawing. The bottom line here, it will be your gridline system should be more or less similar to the architectural drawing, as the contractor is going to refer to both your structural key plan as well as the architectural floor plan. They need to cover both the structural part as well as the aesthetic part. If you have totally different gridline system, this will lead to the confusions of the contractor, and this is going to cause them a lot of trouble for the purpose of referencing. That is the second point. Refine the gridline as necessary, which is on basis of the gridline system as given by the architect. Next, your structural key plan should properly level the structural elements. There will be beams, slabs, columns, and foundations. You need to provide sufficient details for the referencing purposes to effectively deliver the information to the contractors. This gives you an idea in terms of the size of the beam, where the width is 150, the height it will be 450. As for the slab, it gives you an idea whether it is one-way slab or two-way slab, as well as the numbers of the slab. As for the column, there will be numbers of the columns. This will later be referred in concurrent with the column schedules. And there will be foundations and X numbers, which will later be referred with the foundation schedules. Now probably let us look at some examples. For example, this is a ground floor key plan of a building. You will see a lot of grid line here, and you know that this grid line system will be in accordance to the grid line system as given by the architect for easy referencing. And the layout here are representing the layout of the beams. The yellow line here are for the beams, and the green word here in the bracket represent the size of the beam. If you look at this element, it is a continuous beam. You have two sections here. For these sections, it will be 230 times 350. That means the width of the beam is 230, and the height of the beam it will be 350. All units are in mm. And then starting from this section onward, it will be 230 times 450. That means the width is 230 and the height is 450. There are slabs. There will be slab numbers indicating which slab it is for easy referencing when it comes to the detailings. There are also columns, which normally beside the column there is a number of the column, which in this case is C9, that you will need to refer to the column schedule. This is the C9, which you see there are so many sections in the column schedule. This will be due to different stories of the columns. There will be stump, which is located between the pile cap and the ground floor level, which is the stump. It indicates to you the lapping length of the reinforcement bar, where during the constructions, you know that the casting it will be done level by level, where you need to have extruding starter bars to be lapped with the reinforcement bar of the subsequent column. There will be the columns between the ground floor and the first floor, which is this section, and then the first floor to the second floor, which is these sections, and etc. In the column schedule, it will give you the reinforcement bar, the stirrup, where the details are listed here. The size of the columns are given. The link in the columns are also given, which is separated into two types of ties. One is the outer ties, another one is the inner ties. Outer ties represent the shear stirrup, and the inner tie represent the ties that ties the reinforcement bar, especially the intermediate reinforcement bar in the columns. Normally, the inner ties are required when you have the reinforcement bar more than 4 units in the column, where these reinforcement bars are not placed at the corners of the columns. And there will be the main reinforcement bar as indicated in the drawings. There will also be foundation key plans, which give you information regarding the design of the foundations, the size of the foundations, as well as the layout of the foundations in reference to the grid line. From the foundation layout here, there will be at least 3 types of foundations, which is the P1 pile cap, P10 pile cap, and P12 pile cap. The P1 pile cap is meant for 1 pile, P10 pile caps is meant for 4 piles, and P12 pile cap it will be 5 piles. It gives you dimensions in terms of the exact locations of the center of the foundations in comparisons to the grid line, which in this case it will be 150 mm offset vertical and 300 mm offset horizontal. The numbers of the foundations is very important. You cannot have 2 different designs of the foundations to be in the same number. This is going to be quite confusing, and this will later be referred to the foundation schedule, which give you the information in terms of the detailings. This will be the plan view of the foundations, indicating to you the center locations of the piles, the dimensions of the foundations, the locations of the column, as well as the amount of reinforcement bar provided. There will be cut section in the YY axis and in the XX axis, which can be shown here in terms of the cut section. You will see the reinforcement bar, the main reinforcement and the secondary reinforcement. There will be intermediate reinforcement bars meant to control the surface crack, and there will be reinforcement bar provided as an extension from the pile caps to be properly lapped with the columns. It indicates to you the soffit of the lowest beam. That means in these regions it will be the stump, and based on the detailing given here, the reinforcement bar will be properly embedded in the pile caps, having the reinforcement bar extended into the columns in the ground floor. there will be lapping of the reinforcement bar with the columns, and there will also be the lapping of the reinforcement bar, which is embedded inside the pile caps as extended from the piles. You know that during the constructions, after the pile is set, you will need to hack the piles in order to expose the reinforcement bar to a certain intended length to be embedded in the pile caps in order to ensure the continuity between the piles and the pile caps. There will be lean concrete, which are cast in between the pile caps as well as the soil, as the separations between the structural elements and the soil. Now that we have briefly looked into the structural elements, at least you have some ideas how you're going to produce your key plans, what kind of information you need to incorporate in. Next, in your key plan, you will need to indicate the staircase, the drop or rise, the cut sections, as well as the architectural fixtures theme, especially those are made of concrete, because this is going to be taken into considerations, especially when you need to construct certain member specially designed to hold this concrete theme. For you to imagine better, maybe we can look at the structural key plan here. You need to indicate the locations of the staircase so that the contractor know they need to provide rooms for the reinforcement bar between the connections between the staircase and the slabs. Normally, the details of the staircase are provided, including the directions of the flow, whether it is going up or going down. You can copy this from the architectural drawing and impose onto your key plan. In the case that there are offset in terms of the certain structural element from the grid line, the offset needs to be clearly indicated. And remember to number the staircase for easy references, which in this case there are two types of staircase here. To avoid confusions, you give proper names for the staircase. Next, you need to indicate the drop or rise for the contractor to be able to imagine the different levels or elevations of the slabs. For example, here, it is indicated here, there is a rise of 100 mm. That means in this slab, it will be 100 mm higher than this slab. You also see the line here. Some line appears to be hidden, some line appears to be solid. The hidden line means that this is the suspended slab. The slab level is the same, and there will be beams underneath the slab. You don't see the edge of the beam, but you know there is a beam underneath the slab. But when you see the solid line here, that means the edge is visible from the plan, and the drop will happen here. This will be 100 mm higher, and this will be 100 mm lower. The edge will be here. It is basically on basis on the geometrical drawing. For the things that you cannot see, it will be the hidden line. For the things that you can see, that will be the solid line. Another common place you will have the drop, it will be at the bathroom or the toilet, where there is a 50 mm drop, and such drop will lead to contact of the water, which you need to consider for the water leakage issue. Whenever you have something like this, make sure this slab is laid with double layer of reinforcement, and more reinforcements are to be provided in order to control the crack width to prevent the leakage of the water through the slab. Next, you will need to indicate the locations of the cut section, which from the structural key plan, you have a cut section here. This will later be translated into the cut sections of the slabs, indicating to you the reinforcement bar in the slabs. We will discuss this in detail for the detailing for the slabs. As far as what you need to know now, these cut sections will give you the reinforcement bar, the rise or drop, the locations of the beam, as well as the grid line. There will be slab numbers. It will be in accordance to the slab numbers that you provide in the key plan. This is the one that I mentioned just now to provide additional reinforcement bar in double layer to prevent the leakage of the water through the slabs. This is going to be a bathroom. You will see there are drop here, which is obviously going to contain water. And in your structural key plan, there are some other architecture features, such as you need to indicate the locations of the ramp, a slight gradient surface connecting the lower elevation slab onto the building. There could be architectural features such as the concrete fin. You need to indicate clearly the existence of those fins, as this later is going to affect your design sections of this beam. And then you may also put a note in terms of the common size. Sometimes if you have a standardized size, since that every section is similar, you don't have to repeatedly put into the details throughout the structural key plan. This will make the key plans to be rather messy. Instead, you can put certain notes something like this. All slab thickness equals to 150 mm. UNO here means unless notified otherwise. Or for the beams, all beam size equals to 150 times 450 mm unless notified otherwise. Those statements are normally put together to the title of the ground floor key plan, first floor key plan, and other key plans. It is stated here, all slab thickness is equals to 125 mm thick unless notified otherwise. That means the thickness of the slab are not being indicated here. As long as it is not indicated, that means the slab thickness it will be standardized. It is only when you have indicated the other values such as 150 or 175, that means the slab it will be of different thickness. Similars go to the beam. Here is stated all beam equals to 150 times 450. That means if you do not see any levels in terms of the size of the beam, you will know that this beam sections it will be equals to 150 times 450. But if you see there is a level in terms of the size of the beam, now you know that this sections is going to be 230 times 600 mm. With that said, producing a key plan is not an easy task. There are so many things that you need to consider. There are many aspects that you need to check. This is the area where most of the students can make errors and mistakes. It is especially you don't have to construct the building part by part, section by section. You don't have the experience or not having the habit to check every single details at any part of the building. Normally, based on my experience with the students, there are a lot of errors detected from the key plans. Since that you are doing the assignment, most likely you're going to be first time dealing with the structural key plan as a part of the assignment for your course reinforced concrete design. You're going to try to do the key plan as detailed as possible and ask your group members to check for you. Anything which is unclear, ask them to highlight to you for you to do the modifications. You also see that there is a very high concentrations of informations. When those informations they are complementing each others, there will be illustrations, there will be details which are normally written in text, and it is easily going to be very messy if you don't manage it well. That will be the aesthetic part, which is another part of the assessment criteria. That one, it will be very governed by the amount of effort that you put into your assignment, especially when you need to produce the key plan. You're going to polish your key plan, make it more stabilized and optimized, minimize the possible errors, always check against the architectural drawing, ensure there are no contradictions. You may also try to superimpose the architectural drawing onto your key plan to see if anything that you overlook, any misalignment between your key plan and the floor plan, as well as to cross-check the view, make sure there are no clashing into the windows or the doors, and also cross-check with the cross-sections of the building. Make sure the size of the beam should not exceed the allowable space within the ceiling. You don't want your beam suddenly appear out of the ceiling, and this is going to affect the aesthetic part of the building. Normally, the architect will not compromise on this. Having this said, producing a key plan is rather time consuming. You must put into a lot of effort for you to produce a good key plan. But the entire process is worth experiencing, and it is worth learning, as most of the engineering students, most likely in their futures, going to deal quite extensively with the structural plan, either as the consultant or as the site engineers.